In this tutorial, we'll be using some data that we obtained in the lab by measuring the volume and mass of various amounts of aluminum pellets to determine if density is indeed an intensive property. So this is a Mac version of Excel. I believe this is 10.4, one of the latest versions. If you have a PC, it's going to be a little bit different. If you have an earlier Mac version, it will differ a little bit as well. However, there is enough similarities that you can find your way around by watching this tutorial and make yourself a line graph, which is our goal. I've already put the volume and the mass data here in two columns. You want to make sure that your data is expressed out to the proper number of significant figures. And if you need to change that, what you do is you highlight the cell or the groupings of cells that you want to change, and you right-click or control-click, and that will bring up a drop-down box. And you can choose Format Cells. And there you will choose number for your cells, and you can choose the number of decimal places. You can use a toggle box to switch to as many decimals or as few decimal places as you need. So for me, having all of my measurements expressed out to the hundredths place is what I need. It is what I was able to do using the graduated cylinder that I worked with, and also using the balance that I worked with. The first thing that we're going to do is make ourselves a graph from this. So keep your data highlighted, or if you haven't highlighted it, click and drag so that all your data is highlighted. And what you want to do is insert a chart. You want to choose charts. And what I want to choose is a marked scatter chart. And it looks like this, just with points on the chart, no crazy lines on it or anything like that. So I'll choose that. And my chart automatically comes up with all the points plotted on it. Now, as a matter of protocol, I always like to have my charts on a separate sheet in Excel. So if I right-click or control-click on the chart area, I get a drop-down box, and I can move the chart. And I'm going to move it to a new sheet, and I will name the chart Mass versus volume for aluminum. And I hit OK. And automatically my graph comes up in a new sheet, and you'll notice that there is a highlighted tab there that pertains to that chart. The next thing I want to do is add a trend line. What I want to do is put a line of best fit, a straight line of best fit, through these points. So I click on any one of those points, and they will automatically all become highlighted. And I'll right click or control click, and I get another drop down box. I want to add a trend line, so I add trend line. Okay, and it will automatically put the line there for me. Once I've done that, I want to choose options. And I want to forecast my line backwards so that it hits the y-intercept. So I increase the number of periods until that line hits the y-intercept or the origin. I also want to display the equation on the chart and the r² value on the chart. And then I hit OK. This information has a very small font size, so I can highlight this and change my font size. On a Mac, I have a formatting palette where I can easily change the font and make it larger so that we can read it. This box is a text box, and it also can be moved anywhere else on the graph if you want to move it away from the line. Okay. So now I have my graph. The other thing I need to do is also put information. I need a title. I need to have my y-axis labeled. I need to have my x-axis labeled. So under chart options, I can choose chart title. I can click the title, And when we title charts, usually what we do is we write what's on the y-axis, what value was plotted here. And for us, it's mass. And versus what's on the x-axis, and that was volume. And then what material was being measured. So we have mass versus volume for aluminum. I also need to label my x and y axis. So my horizontal category axis is my x-axis, and that is volume. My units are in milliliters. And my vertical value axis was mass, and my units were in grams. So now I have my labels on my charts. If I want, I can highlight that, and I can increase the font size again to make it larger, so it can be read more easily. So there's my chart. Now, what does this equation mean? This is in the algebraic format of y equals mx plus b. So b is my y-intercept, and it is now negative 0.2441. So if I could extend this line, it would intersect the y-intercept just below the origin. The m here is the slope of my line. Okay. The slope of the line is obtained by rise over run, or change in the y value over the change in the x value. Since my y value is mass, and my x value is volume, mass divided by volume is density, so the slope of this line is equal to density. So we see that we have a density value of 2.7291. which is actually pretty darn close to the actual density of aluminum, which is 2.7. The R-squared value tells us how precise our data is. In other words, how close are the data points to each other, or how close are they to that line of best fit? If the R-squared value was exactly 1, or 1.0000, that would mean that all of the points fall directly on the line. My data is really darn good. It's 0.9999, so really most of the points are right on the line. I think one of the outliers is this first data point right here. It's not unusual when making mass and particularly volume measurements in the lab that the smaller volume measurements are going to be less accurate. It's difficult to measure low volumes using the graduated cylinders that we have available to us in the lab. So usually there's a bit of error there with those smaller values, and you can see that here. But this is pretty good data, okay? We have a straight slope for a line. That means it is a constant slope, which means that the density value is the same for each sample, which confirms that density is an intensive property. Now we can do also an analysis just with the numerical data. So if we click on the tab for the sheet, we bring our volume and mass data back up here. And I can make a new column for density in grams per milliliter. And I can do something really cool with Excel, and that is add a lot of mathematical functions. I want to divide my mass by my volume for each of these cells. If I click on the cell where I want that density to be calculated, there's two things I can do. I can insert a function. And I get a box that pops up over here. On the Mac, it's a formula builder, and I think on a PC you also get a function box. And I want to divide, so if I click down, scroll down, I find under arithmetic, add, subtract, multiply, or divide. I double click on that, I get a box down here that is asking me, well, what numbers do I want to divide? Well, I want to start with my mass, so I'll click on that. And under number 1 in the box, I don't get the number. Well, I do. It's right there. But I get the cell. Okay, cell B2. Cell B2. And then my next number is what I'm dividing by. And this is A2. We see a cell A2 right here. My operation is not add, but divide. Okay. And if I hit return, the calculation is done for me. If I look up in the function box up here, I see equals B2 divided by A2. And that is how the function is written out. So you can actually just directly type this function in instead of going through the motions of clicking on the correct values in the drop-down box. If I want to perform this operation for every single other cell underneath it, I don't need to go through that procedure over and over again. Simply what I do is highlight this box, and I put my cursor here in the corner till it turns like a cross. And I click and drag all the way down. And what that will do is apply the function to all of the other boxes. So if I click on the one underneath it, and I look at my formula box, now it says B3 divided by A3. And I click down on this one, now it says B4 divided by A4. So Excel has automatically applied the functions that I need for division for each of these cells. Now you'll notice that the decimal places to which the density was calculated are not expressed to the proper number of significant figures based on the values that I have. If I look at the first three cells, I have 3 significant figures in each of the volume and mass values, and that tells me that my density needs to be expressed out to 3 sig figs. So I highlight these first 3 cells, right or control click, format these cells, choose number, and choose 2 decimal places. Now they are expressed out to 3 sig figs. If I look at these next cells, I have 4 sig figs in my mass, but I still have 3 in my volume down here to cell A9. So from here down to here, I still need 3 sig figs. So I'll right click or control click, format cells, under number, choose 2 decimal places. Okay, seems like I forgot one guy here. So let's fix that one. Okay, and then on my last one, I have 4 sig figs in each of my values. So my density needs to have 4 sig figs. So when I format my cells here, I'm going to add an additional decimal place to give me 4 significant figures in the calculation. So now I have my density values. I could calculate an average density if I click down here. Let's say I want to put my average value right here. Again, I could insert a function. Okay, and over here I could choose average. And if I hit return, that equation will automatically come up here in my function box. And it is equals average in parentheses C2 colon C10. And what this tells me is that it is averaging the values in cell C2 down and including C10. So if I hit return, there is my average value, 2.67. So I'll boldface it so it sticks out and is separated from the other values, so I can see that that is indeed an average. Okay, so this is my average density based on all of my measurements, 2.67. If I look at my graph, the density that I found from a line of best fit was about 2.72 or 2.73. So we had 2 slightly different values there. We had an average, which is including my lower outlier here. Remember how I said that this lower value, this very low volume of 2.1 milliliters, probably would result in a much lower density, and it did. That density was pretty far off the mark. That's lowering my entire average. If I look at my graph, the line of best fit really doesn't, it's not averaging, so it's not taking that point into account. It's actually keeping that point off of the line. So the line of best fit oftentimes is a better way of determining the values if we want to find something that is intensive, like density is. So that is Excel in a nutshell for analyzing, doing some basic data analysis, and graphing.